Okay, here we are. In this next video, we are going to learn how to multiply and divide rational expressions. It's just math. Y'all can do it. Come on, let's do it. Here we go. All right. So now we're going to multiply and divide rational expressions. Okay, now the steps for multiplying are basically the same as simplifying. We factor the numerators and denominators completely. We divide out the common factors and then we put it back together. But the reality is that we don't really multiply it back together. We leave it in factored form. Okay, so we leave in factored form because it's easier that way. All right, so you don't have to actually multiply it back together. So that's kind of good, but we do kind of put them together. All right. Division, you have to go back to the rules for dividing fractions. When you divide by a fraction, you have to flip the second one and change it to multiply. So we have to incorporate that into what we do. And then basically, when you put them back together, you really aren't doing the multiplication, you just kind of write them together. So here we go. So this first one is just a simplify problem. It's not a multiply problem. I don't know what happened to the multiply problem. Maybe we could make it a multiply problem. Let's change it. Let's make it a multiply problem. Let's make it, nope, let's don't. Let's just do it. Let's factor the numerator and the denominator. The numerator is a difference of squares. It's a special case. And the denominator is n plus n. It doesn't factor. And so I'm going to divide that out, and I just get m minus n. So that's really not a multiply problem, so I'm not sure why it's in here. Okay, let's go to the next one. The next one is a divide problem. Whoa, Nelly. Whoa, Nelly. Okay, so we have to factor everything first. That's the first thing we have to do is factor everything. So now if you'll notice, the first problem, the first numerator is not, it doesn't need to be factored. It actually just needs to be written out. Remember that 3 there means there's 3 of them? So that numerator is actually just, we're going to just write it all the way out. It's in factored form, but I need to write that all. Now the denominator, I have x squared minus 9. That's going to factor. That's a special, x minus 3, x plus 3. Okay, now these two I've got to flip and factor and change it to multiplication. So again, they're both going to be binomials. I know that. I may go over to my scratch paper and work on it. So x squared plus 8x plus 16. I need two numbers that multiply to give me 16, and then are going to add to give me 8. Well, that would be 4 and 4. So this is going to be x plus 4. Wait a minute. I didn't flip. I got to flip it. That one's got to go down here. X plus 4, x plus 4. Okay, and then the x squared plus 6x plus 9. Two numbers that multiply to give me 9. That are going to add to give me 6, or 3 and 3. It'll be a plus 3 plus 3. Okay, so this one's x plus 3 and x plus 3. Okay, so I factored and flipped. This one goes here. That one goes there. Change it to multiply. Okie dokie. Now here comes all the fun part. Sorry about that. I still haven't figured out why it does that to me. It's very frustrating. But here we go. So I'm going to cancel out some stuff. So now I see an x an x minus 3 and an x minus 3 there. So that's a 1. I see an x plus 3 here and an x plus 3. That's a 1. I have an x plus 4 and another x plus 4. Another x plus 4 and another x plus 4. Alright, so now my denominator's done with. Let's check out my numerators. I have an x plus 4 in the numerator, and I have an x plus 3. And that's my answer. And technically the denominator is 1. Because see, there's 1s all across the denominators, and I don't need that. As a matter of fact, the computer might mark it wrong if I type that in. So there we go. Okay, number 3. All right, you want to stop the video and then work on number 3. I'm going to quickly factor all of these. Get back to my white. I'm going to factor that one. I'm going to factor the bottom one. This one's multiplication. That's going to be a trinomial, but this one right here, it's not a trinomial. That's GCF. It's not a trinomial, it's a GCF. So that's going to factor into x plus 1. Okay, stop the video and get all those factored, and we'll come back. Here we go. So that's x minus 1, x plus 1. This one's going to give me a 3x goodness, what is that going to be? It's going to be a 3x, and there we go. It's going to be 3x minus 4 and x minus 1. Make sure that's right. All right, and then the bottom one, it's going to be a 4 and a 1, but it's going to be minus 4 plus 1. There we go. All right. Those were kind of hard. Got them all factored. I hope they're right. Y'all let me know if I'm wrong, right? And so that's a 1. And that one matches that one. So that's a 1. And that one matches that one. So that's a 1. So now what I have left in the numerators, I have 1 times 1 times 1 times x. And in the denominator, I have x plus 1. There we go. This can be very satisfying. A lot of people say it is. They say it's very satisfying to do all this. It's just math, y'all. You can do it. Let's go back and look at our procedure. We're going to factor it, divide out the common factors, put back together, or just leave them factored form. Okay. It's just math, y'all. You can do it.